So here I am in Composer, and what I'd like to do is to show how to remove this particular component. And the challenge here is that I'd like to create an animation so that I can show the user exactly how to avoid colliding into these side walls. And even on the front side, I need them to be aware that there are some geometry that needs to be cleared before they can start actually rotating this thing. And maybe there's a certain degree of rotation they can do. There might be a little bit of play here, but I'd like to create an animation to do this. And in Composer, it's really easy to create some nice visuals that can highlight things to users, and it's very fast to create animations. However, this type of situation where you have tight-fitting components that need to be shifted, translated, rotated kind of all at once to give you the right type of extraction or assembly can be tough to do or take some time to do. But what we have to help with that is 3D via path planning. And this is an integration into KineoCam software to do some interactive collision detection in the context of an animation. And what I'll do is I will select this assembly. I'll go ahead and move it out like this. Now obviously this would not be the right way to remove this part. You can see it crashes through the wall there. But what I'll do is I'll use path planning, and I'll tell it to say on highly constrained initial position here, because that's where it's constrained, and I'll go ahead and I'll solve this. Now this is actually passing data over to KineoCam, and the engine internally is running and determining the non-colliding extraction path, and as it's doing that, it's recording the keys, and it's going to put them right into the timeline for all the locations for the extraction of this in a non-colliding way. And when it's done, you'll see the location keys being set here on the timeline. And what I'll do is I'll just tell it to optimize the locations so that we have a smooth path. And now I'll just hit the play button and see the result. Take a look at a different angle here. We can see we're not colliding in the back. We're kind of lifting up and kind of turning it as we go. And if we take a look at the front side here, we can see that those bosses are not going to collide. And as soon as they break clear of their interference potential, then we can continue to move this thing out of the way. So there's an example of KineoCam only taking a couple of seconds to build a very nice path that can explain to people exactly how to go ahead and do this. Alright, in this example what I'd like to do is to show how to remove this assembly that I've colored in gold. And if I link to the actual removed procedure, or the removed position, it actually isn't providing me with enough information on how to actually go ahead and remove this piece. So we'll go into animation mode. We'll drag this starting view down and this ending view, and I'll go in and select those parts, go ahead and go into path planning mode, highly constrained initial position, and solve. And again, just like the previous example, behind the scenes the KineoCam engine is being called. Composer is sending the starting and final coordinates here, and KineoCam is determining all of the various paths that are available that are not colliding. And it's doing this all seamless to the end user, so 3D via path planning is doing all this communication on behalf of the user, and KineoCam is doing all the heavy lifting. And when it's done, it's going to return the set of keys, of locations for these parts, so that they can be animated on the timeline. Okay, so in just less than a minute, if we go ahead and play, now we have a very good animation of how to remove this assembly. It's very clear. I have to rotate it and kind of turn it a little bit to get it under the windshield. And what's great now is I can go back to my starting view and I can edit this link and have it link to that marker sequence that we just created. So now the user, when they click on this instruction, they can click on the link, and now they're going to get the animation of how to remove it. And now it's very clear. So something that is complicated to explain, I've now given an interactive link into a very rich animation, and it only took me about a minute or so to create all that. And this last example is kind of a fun one. What I'd like to do is take this ball and have it find a path outside this labyrinth. Obviously, we can't go through walls, so we want the system to go in and find the path here. There's several paths available. One of the paths, actually, because there's no lid, will be to come straight up and come straight over and out. Now we want to prevent that from happening, so I'll go into Composer here and we'll just create a disk, and we'll lift that disk up, say like that, and we'll get the properties of everything else and just make it a little bit more transparent so we can see through it. So we have a piece of geometry blocking the top, so the system can't actually calculate an upward rising path. Now we'll go here, say to 5 seconds. I'll select this and we'll just slide it right out here. We'll go into path planning. This time it's not constrained in the initial or final position, so we'll go ahead and solve it. And we'll get our result, or a result, and we can see now that the ball is going to wind its way around and come out. Now let's say that I don't want it to come out that end point. Well, just like I didn't want it to come out the top, I can go into Composer and just delete all those keys that we didn't want. And again, I'll just create like a wall. We'll put the wall right here. Block it so it can't come out. And now we'll go back into path planning and solve again. And now, if it comes to that wall, it won't be an option to remove it. So using some primitives this way can help you to build a more ideal route if there's multiple routes available. You can kind of block them off with these geometry primitives as needed. So that's 3D via path planning, a great way to very quickly create animations when you really need an animation to explain a more complex process to your workers.